So first, virtual private database. Well, what is it? It's a declarative technique for enforcing security. Typically, it's based on use of application contexts. That was the first limitation with 8i. Back with 8i, contexts were session-specific. The context variables were stored in the PGA, and that meant you simply couldn't use it in a web environment. However, when global contexts were introduced with 9i, virtual private database became usable for web applications with connection pooling. But whether you're using it client-server or in a three-tier environment, it's a declarative technique rather than a programmatic technique. I can go behind the back of the application as a DBA and generate predicates that get appended to all SQLs. Select, insert, update, delete. The end users issue the SQL, and I will generate a predicate that filters the access. It's impossible to bypass. All users will have predicates appended to all their code. And it doesn't matter whether they're using SQL+, Discoverer, Business Objects, Crystal Reports, eBusiness Suite, whatever they're using, I as DBA can filter their access to rows. The end result, different users see different data sets while running the same code and accessing the same tables, hence the name virtual private database. Different users will think they're seeing a totally different set of tables, but in fact it's one common database, one set of tables, hosting a single application shared by all the users. Now, the mechanism. You can apply VPD to tables, to views, to synonyms, and a declarative technique. What's the technique? You write a function that generates a predicate. You associate the function with a table. From then on, whenever the user issues SQL against that table, the cost-based optimizer rewrites the code. The cost-based optimizer rewrites the user SQL to call the function to generate a predicate. The predicate is then appended to the SQL, and it's the modified SQL that is parsed and executed. So let's see how this actually works. Now, I'm working here, by the way. This is just a perfectly normal 12.1 database. But what I'm going to demonstrate at this point will in fact work on 11G as well. I'm not going to be using any of the 12C enhancements to VPD for this little demonstration. I'll work in the Scott schema. So what do we have to do? We write a function to generate a predicate string. So create function, and I'll call my function VPDF. The function must conform to a fixed specification. It must take 2 varchar arguments. One of the arguments is intended to be the schema to which the function will be applied. The other argument is the object within the schema to which the function will be applied. And it must return a varchar 2, which is the generated predicate as begin. Now within this function you can do just about anything. There are some limitations. It's impossible for the function to query or update the table against which the VPD policy is going to be applied. That would violate the rules of purity that we come across so often with PL/SQL. But apart from that, it can do just about anything. Any sort of, including a number of dreadful side effects, can be introduced by writing VPD functions. I'm going to do a very simple one at this point. I shall simply return immediately a predicate. What predicate? ename, which is the ename column from the scott.emp table. Ename should equal syscontext. I'll go to a local context, my user env context, and just extract session user. Oops, let me drop that. Drop function VPDF.
We can see that John has tested this earlier today, and therefore the object already was existing, and he's just dropping it now and cleaning up the recreate.
Exactly. I hope you realize these really are live demonstrations. I'm not just running scripts. Now, so I've created a function. What's that function going to do? It's going to return this value here. Test it. Always test it and see what it's actually going to do. I'll select VPDF. Have to give it a couple of arguments. Just meaningless ones will do for now. From UL. So that's what it's going to generate. ename equals syscontext user m session user. So when I apply this, my policy to a table, any query that hits that table will have where ename equals that added onto it. And what's that actually going to generate? The syscontext call. It just generates and returns my current logged on schema. So, having created the function, what do I do next? I associate the function with a table. Now, I'll do it and then run through the API. So, DBMS RLS for a level security, and add policy. Now, the policy will be applied to scott.emp. I'll give the policy a name, my policy. That's just an arbitrary name. And then the function I'm going to apply, which is scott.vpdf. So that associates scott.vpdf with the table scott.emp. Now, test it. Select star from scott.emp, and I get one row back. Well, we know very well there are 14 rows in the table. But even as the owner of the table, I am logged on as Scott. I see only the row where the ename column happens to match my logged on schema. To take it a bit further, if I create a user, well, let me just create user Miller, identified by Miller. I've already got it, and that's fine. I'll grant him a couple of privileges, make sure he can log on. Grant create session to Miller, and I'll give him select any table to Miller. Oops, yeah, that was an underscore. Select any table to Miller, and then connect as him. And what happens when he runs the identical code? Scott ran that code and got that row back. Miller runs that code, identical code. He sees a totally different subset of the data. Finally, if I create another user, create user JW, identified by JW, oops, connect /sysdba, and now do it. It exists already. User JW, and I'll give him one or two extra privileges. I'll grant him DBA, and I'll also grant him exempt access policy. Exempt access policy to JW. If I connect as him and run the same code, now I see the entire table. Why? Because of that privilege is there. And note how good the protection is, even if I connect as user system. Not even as user system can I see the data. And the predicate generated in this case, of course, there is no one in this table whose name is uppercase system. So not even a system with a DBA privilege can I bypass this. Now, this really does block absolutely everybody from seeing data. I've taken an extremely simple predicate, by the way. I'll give some examples of more complex ones that would perhaps be of more use in a business environment. Well, what's actually happening? Well, just a very brief bit of reverse engineering. Connect to Scott. I'll set autotrace on and get out the execution plans. So I run my query, select star from scott.emp. There we are, full table scan, but there we see a filter coming in, ename equals syscontext. So that's a simple demonstration of what's actually going on with a virtual private database. We take the user SQL, and in the background, the cost-based optimizer rewrites it to append whatever predicate we happen to want to use. Now, user issues the SQL, we generate the predicate, add the predicate to the SQL, and then it's the modified SQL that's actually parsed and executed. Now, what can you do with this? What it's for is clear. It restricts access to data, filters access to rows. What I haven't demonstrated, because we don't want to spend too much time on this, is you can also apply it to individual columns rather than rows as a whole. That means that depending on which columns you project, the filter may or may not be applied. Now, there's lots more. There's lots more. The filter itself. The filter can be based on many criteria. I just use my schema logon. Usually one would use something much more sophisticated than that. Session attributes, who the user is, perhaps his role in an organization, perhaps what it values stored as cookies in his browser. Any session attributes, environmental attributes that let Oracle work out who is this guy, what data is he allowed to see. If you really want to make it confusing, you can have different policies for different statements. I did say I'll just show you the relevant package, DBMS RLS. The critical procedure call is add policy. Table the policy is going to be applied to, the function you're going to generate, and then you can have different policies for select, insert, update, delete, which can make things really confusing. But you might well be allowed to see certain rows, but only update other rows. These are to do with performance, very important indeed. These are to do with column level VPD rather than simple row level VPD that I worked on.